Alrighty, this is going on page 36 when we are done. Everybody paying attention? All right, so we're going to look at one and two-sided limits. This is another thing that I am front-loading you with. We have talked about limits, but we've just looked at limits at infinity when we're looking at in behavior. Now we're going to look at some of the middle behavior. And in order to kind of explain limits a little bit better, I'm going to show you a short video that I think is a very good explanation of limits. So pay attention.
In a general sense, limits allow us to determine what value a function is approaching when we use a particular input. Not necessarily what the function gives us as an output, but rather what value it's getting arbitrarily close to. Let's explain limits using an analogy. Suppose you are watching TV and start getting a massive craving for pizza. Fortunately, you just happen to have some leftover pizza in the kitchen. So you get up from the couch and start heading towards the fridge. In this instance, if someone were to describe where you are going, they would say you are approaching the fridge. They would be confident in their description because as you keep walking, you are getting closer and closer to where the fridge is located. This example is the same thing we want to do with functions. When we take the limit of a function, we are describing where they are going. Let's see an example of this with the function 3x squared minus 1. For this function, I'm really curious what value the function is approaching as I use x values close to the number 2. Let's see this by using some inputs like 1.9, 1.99, and 1.999. When I use these, I get values such as 9.83, 10.8803, and 10.988003. From these values, it appears that the function is approaching 11. So we say that the limit of the function as x approaches 2 is 11. Remember, what I'm really saying here is that we can get arbitrarily close to the number 11. I just have to pick values that are sufficiently close to 2 in order to do it. Now at this point you might be thinking, that's fantastic, but couldn't you have also found the limit simply by plugging 2 into the function? Wouldn't that also give you 11? In this instance, the answer is yes. But the focus with the limit should be on what value it's approaching, and there are some functions where you simply can't plug in a number to find the limit. In other words, they are not always the same. Let's cover this by going back to our pizza analogy. Like before, you've been struck with a craving for pizza. So you are headed towards the fridge for a quick snack. Now, in one scenario, the fridge is there, loaded with pizza, and you can easily satisfy your craving for pepperoni. But in an alternate scenario, the fridge is gone, possibly stolen by pizza-craving ninjas, and you are left empty-handed. Even though both of these situations are completely different, your behavior leading up to them is exactly the same. In either case, you are still approaching the fridge. This is the key difference with limits. They are used to describe what value a function is approaching. They are not used to describe the value the function actually reaches. Let's see how this works with yet another function. Let's go ahead and use x squared minus 4 all divided by x minus 2. Like before, we are interested in what value the function approaches as we use x values close to 2. Let's go ahead and choose some inputs like 1.9, 1.99, and 1.999. When we use these, we get values of 3.9, 3.99, and 3.999. From these, it appears that the function is approaching 4. So again, we say that the limit of the function as x approaches 2 is 4. If you try and find this value by instead plugging in 2, something strange happens. When you plug 2 into the function, you get 0 divided by 0. This shows that the function doesn't actually ever get to 4. In fact, a quick look at the graph shows a hole right where 4 is. Despite the hole, the behavior of the function leading up to it is the same. Since the behavior is the same, we still say that the limit of the function as x approaches 2 is 4, even though it never actually gets there. Hopefully both of these examples really highlight how limits focus on the behavior of a function, what they get arbitrarily close to. One thing we still have left to cover is what it exactly means when we say that a function gets arbitrarily close to a value. But don't worry, we'll be able to tackle that tricky problem in the next video when we introduce epsilon and delta. Thanks for watching. Hey.
Okay. We will not be introducing epsilon and delta. Not that you even know what those things are, but all right. So that's the concept of a limit, which we really have already talked about. But want to make sure you understand, since we had only been talking about the infinities, you know we're never going to make it to infinity. I might be approaching 3. Maybe when I get there, 3 is not really there. The other thing we're looking at is 1- and 2-sided limits coming at it from both directions. So you might be approaching the fridge from the living room, but I'm approaching the fridge from the garage, and we would end up at the same spot, right? So that's kind of what we're looking at here. So your one-sided limits, the notation looks just a little bit different. If I have a limit from the left, then the value of f of x approaches a unique number as x approaches c from the left. So notice here, instead of underneath it, it's saying as x approaches infinity or negative infinity, it says x approaches c, which would be like a number like 5. And then with this little minus sign and the little exponent, like where the exponent would go, that means I'm approaching it from the left. All right? And then if I have a right-sided limit, I have the value of f of x approaches a unique number as x approaches. Remember, we might not actually get there. And then it says left again, which makes no sense. So we're going to change that to right. And then the c has a little plus sign, which is easier to see on your paper. On my board, it looks like a blob. But that means we're coming from the right. Not going to the right, coming from the right. Okay? One thing that might look a little other than the little plus and minus up there is that we have been writing limits like this, like the limit as x approaches infinity of f of x equals, where we've been putting like the name of the function here. I can have the name of the function or I can have the actual function. Either way, it doesn't matter. If it's a long, crazy function like this, this is why one reason why we'd want to be able to just say f of x. Okay? All right, so let's look at this example here. This says evaluate each limit using this graph. And so I'm evaluating the limit as x approaches 2 from the left. So as x is approaching 2 from the left, I can't even draw a straight line. What is y approaching, do you think? -1. And that's a weird one sometimes for some people because we're actually already there, right? I keep saying we may not actually get there. Well, we've been at -1 the whole time. But as x is approaching 2 from the left, do I actually get to, when I get to 2, am I at -1? I'm not, because there's an open circle there, right? But I'm approaching it. So the limit is -1. And as I approach 2 from the right, then my limit is 1. Okay? So this is what happens when you're trying to build bridges or tunnels from 2 different places and the math is off. They go like this, but they don't actually match up, right? So that would be a bad thing. This is why decimals matter. Yes, it's always about the y. Just like on the other ones that we've been doing, as x approaches this, what is y approaching? So because it's the limit of the function, and your function value, remember, is always your y value. Okay, very good question. We good on that? All right, so I've got all these functions here. To avoid giving you like 10 pages of notes so you can see a ton of graphs, I have these graphed in a Desmos activity that I'm just going to show you up here, and then I'm going to assign it to you. You don't necessarily have to do anything with it, but if you want to go back and go over your notes for something, you'll be able to access these same graphs. Does that make sense? But it's just easier if we go through them together. So I'll click back and forth like once, but then you got to just be writing down the answers as we go. All right, so this number 1, this crazy looking function here, because we're doing this graphically right now. This is what the graph looks like. Okay? So the first part says the limit as x approaches -3 from the left. So as x is approaching -3 from the left, what is y approaching? -2, exactly. So write that down. And as x approaches 3 from the right, what is y approaching? -7. Good. Okay, so -2, -7. Any questions about those? All right, so again, you be writing these down as we go. I'll come back and fill this in, but I'm not going to flip back and forth every time. All right, so this next graph looks like this. The limit as x approaches 0 from the left. As x is approaching 0 from the left, what is y approaching? 1. And as x approaches 0 from the right, what is y approaching? -5. Okay, you see how that works? And it really is that easy. There's no trick to this. I know sometimes you're like, all right, but like, what is it really? All right, now on this one, you have to ignore the little vertical parts here because that's just because it was an absolute value and I don't know how to fix that. So we just pretend like the vertical part isn't there. We're on number 3. We're looking for the limit as x approaches -2 from the left. As x is approaching -2, what's y approaching? -5. Not only am I approaching it, I was already there. Okay, sometimes we get there, sometimes we don't. I'm approaching -2 from the right. What's y approaching? 5. Perfect. Good. What? Okay. Stop me if you got a question, especially if I'm not paying attention to what you're asking me here. All right, so then on 4, I want the limit as x approaches 1 from the left. As x is approaching 1 from the left, what is y approaching? Infinity, right? Because 1 looks like it should be the asymptote, right? And then as I approach 1 from the right, -infinity. Okay? Not necessarily. That's a good question. Let's do some other ones. All right, number 5. The limit as x approaches, I can't read that, it's a blob, 4? -4. -4 from the left. And yeah, -4 from the left, I've got -infinity. -4 from the right is infinity. And then 6. Now this is a trig function. We'll talk about trig functions next semester, but we can still do this. Look at your x-axis in the scale. It's in terms of pi's. This is 2 pi, this is pi. So what do you think that would be? Half a pi, or pi over 2. And that's what we're trying to approach. As x approaches pi halves, now pi halves looks like that would be my asymptote, right? So as I approach pi halves from the left, y is approaching infinity, and pi halves from the right, -infinity. Okay? Any questions at this point? All right, stay on that side of the paper. I'm going to fill these in real quick, and then we're going to talk about the bottom down there. So -2, so 1, -5. Hopefully you were actually filling those in. All right. So down here we have, it says an existence of a limit. A two-sided limit. So those were one-sided limits, just coming from the left, coming from the right. A two-sided limit exists if and only if both the left and right limits exist and are equal. So if I just said the limit as x approaches 2, then I have to be, like the limit as I approach the fridge, right? We've got to, as we're approaching that, we got to end up in the same spot there. So if I looked back up here, let's just look at number 2. And so we did, as we approach 0 from the left and the right. If I just have the limits as x approaches 0, I don't have any left or right, just 0, of f of x. Well, since the left I approach 1 and the right I'm approaching -5, this limit does not exist because I have to be approaching the same thing from either side. Okay? Does that make sense to you? All right. So down here, what? Yeah, for all of these, the limit, the two-sided limit for every single one we just did does not exist because they all approach something else. All right, so the limit as x approaches c, not from the left or right, just the number itself, it will equal a number if and only if the left limit is equal to the right limit. You have to be approaching the same thing from either side. We both have to end up at the fridge. You're coming from the living room, I'm coming from the garage. We meet at the refrigerator. Okay? We good? All right, so flip this over. Let's look at some more. Now, some of these are written as two-sided. Some of them are written as one-sided. But we're going to look at graphs for all of them. So number 7, I want the limit as x approaches 2. All right, so as I approach 2 from the left, now I want you to see what happens. Of course, I think my hand's going to be in the way. And see, as soon as I do that, and I can't keep my hand steady enough. Okay, look, when I'm at 2, it's undefined because there's actually a hole there. So this is one that I couldn't just substitute the 2 in. But as I'm approaching 2 from the left, and as I'm approaching 2 from the right, am I approaching the same number? Yes. And what number is that? -2, because it's the y value. Make sense? It's the y value. So this is -2. We good with that? All right. Number 8. The limit as x approaches -1 from the right. As I approach -1 from the right, what's my answer? -infinity. Good. Number 9. The limit as x approaches -4. What do you think? Do you think it's... Where's the asymptote? -3. The asymptote's at -3, right? Here's -4. So be careful. Just because we have an asymptote doesn't mean that that's what the question is asking. If this asked as x approaches -3, then this one we go to infinity, this one's going to -infinity, so it would be does not exist. But it's asking about -4. So as x is approaching -4, from both sides, I'm approaching the same number, right? And what's that number? 4. See how that works? Be careful. I put that one on there on purpose because when you see asymptotes, everybody wants to head for that, but make sure that's really what they're asking you. All right, number 10. The limit as x approaches 3. So it looks like I have an asymptote. Do you think the asymptote's at 3? Yes, okay, and if you weren't sure, you could use the function, but I think so. So from the left, I'm going to -infinity. From the right, I'm going to infinity. So my limit, what? Does not exist, exactly. Right, like on this one, what are we on, 10? Right, so that means that's why I have to look at both sides, and if they're the same, that's my answer. If they're different, it does not exist. Okay? You good? Yes. Then it doesn't exist. Exactly. If it doesn't have, yes. Okay, so if it doesn't have this sign, if it doesn't have the little plus or minus like this one does and like this one does, and they're different from either side, that's when it does not exist. Okay? Yes, it will always include that. There won't be any little tricks there. Okay.
If they're the same, so it has one.
Okay, I think so. Let me see. Let me explain it, and then you tell me if I'm explaining what you're asking. If I have a plus or minus up here, it's a one-sided limit because I only care about either coming from the left or the right. If there is no sign, do we stop on 10? If there is no sign, then that means that's a two-sided limit, and I got to look at both sides. Okay, does that help? Is that what you were asking? What other questions do you have? Those are good questions. Okay. Let's look at 11. 11, well, first of all, is 11 a one- or two-sided limit? One, because I'm asking just from the left. So as I come in from the left, what is y approaching? -infinity, exactly. All right, is 12 a one- or two-sided limit? 2. So as x approaches 1 from the left, and as x approaches 1 from the right, are we approaching the same thing? Yes, and what is that thing? Infinity. Okay, so let me write these two down because, see, this is -infinity. This is infinity. We're going to put a little asterisk or a little star here because we're going to come back and talk about that one at the end. All righty. 13, is that a one or two-sided limit? 1. So I'm looking for the limit as x approaches 0 from the right, which would be infinity. 14, is that a one or two-sided limit? 2. So as x is approaching 0, are we approaching the same thing from both sides? No. So what is our answer? Does not exist. Exactly. We good on that? Question? You good? All right. 15. One or two-sided? 1. And we're only coming from which direction? The left. As x approaches 5 from the left, y is approaching what? -1. It's really over there, already there, but yes. 16. Okay, so 16, well, first of all, is 16 a one or two-sided limit? 2. All right, so as x approaches 1, would you agree that we are approaching the same thing? Whatever it may be. Okay, so here's one where I gave you a little chart because you can see these with the chart as well. If you did, you'd have more values to look at. I just know it's already kind of hard to see this, so I don't want to put too many in there. But I would be getting closer and closer to 1 from either direction. So as I'm coming from the left, I did 0.999. That gives me 0.50012, blah, blah, blah. At 1, it's undefined, right? Because I can't divide by 0. But just on the other side of 1, or if I'm coming from the right, I'd have 0.4998, blah, blah, blah. So if this is kind of in the middle of this, from either side, what number do you think I'm approaching? 0.5, exactly. That makes sense from a table perspective? Okay. And that's kind of, there was a homework question way early on where you had to do a bunch of stuff on the calculator, and then it was like, well, what do you think f of 3 is, or whatever it was, and it kind of blew your mind, but yeah. Okay, because if I am approaching, if I had a bunch of numbers, okay, so like I might have some other ones up here like 0.501 and then 0.500 and then undefined and then 0.499 and 0.48 and whatever. It's because I can't, if I'm getting closer to 0.5 by getting smaller and closer to 0.5 by getting bigger, I'm not all of a sudden just right here going to be at infinity. Okay, it's kind of like where does it fit on the number line type of thing. Does that help? And we'll look at some more of the table ones. I just wanted to throw that one in there. But there's not. I'm approaching 1. When I approach it from the left, I end up here. When I approach it from the right, I end up here. When I actually get there, I'm undefined. If I can actually get there. There you go. See? So, but as I'm approaching it, I'm approaching, shoots and ladders. Okay. So do you see how my y value, I'm at 0.38, it's getting bigger and bigger and bigger, and it's getting closer and closer to 0.5, and then I'm undefined. When I'm coming this way, I'm at 0.6, it's getting smaller and smaller and smaller, but it's approaching 0.5. No, the value is undefined, the limit is 0.5. Because remember, you showed up in your kitchen because you were heading to get pizza, right? But the pizza craving ninja stole the whole refrigerator and everything. But your behavior was the same. You were approaching the refrigerator. Whether it's there or not is irrelevant. Because it's undefined, your refrigerator's gone, but you're still approaching it. Okay, does that help? Okay. Can y'all wake Jenny up, please? She's going to do jumping jacks back there or something. We good? Okay. 17. Is 17 a one or two-sided limit? 2. Okay, as x approaches -2, am I approaching the same thing? -2. I'm sorry. Wait, what does it say? Am I making this up? It is -2. I said 2. I'm sorry. If the answer to, okay, if I was approaching 2, am I approaching the same thing? Yes, but that's not what the question actually asks. It asks -2. And then I am not approaching the same thing, so what is my answer? Does not exist. Exactly. 18. One or two-sided limit? 1. Which side am I coming from? The right. So coming from the right, as x approaches -3, what's y approaching? 0. And I actually get there this time, but sometimes we do, sometimes we don't. Yes? Uh-huh. Yes, very good. So her question is, if this was a two-sided limit, would my answer still be 0? And the answer is yes. Like, this is a piecewise function, right? But as I'm approaching -3 from the right, I'm approaching 0. And as I'm approaching -3 from the left, I'm approaching 0. Now, on the red one, when I get to -3, it's actually undefined because it's not included, but I'm still approaching it. So yes, two-sided limit would also be 0. Good question. Anything else? Jenny. All right. 19. The limit as x approaches -infinity. What do you think it is? As x approaches -infinity, y is approaching what? 0. And then look at your function. Does it make sense that it'd be approaching 0? Where's your horizontal asymptote? Is it top heavy, bottom heavy, tied in degree? Bottom heavy. And if it's bottom heavy, your horizontal asymptote is at y equals 0. So that makes sense, right? That's your horizontal asymptote. 20. The limit as x approaches infinity, which technically these are one-sided limits, right? Because you can't get on the other side of infinity, but we don't put the plus and minus on there. As x approaches infinity, now this looks like maybe it could be one of those where it crosses, but we can't tell because it just sort of becomes one with it. But look at the function. Top heavy, bottom heavy, or tied in degree? Bottom heavy, so where's your asymptote? Y equals 0. So as x approaches infinity, f of x is approaching 0. Good job. All right. 21. As the limit as x approaches infinity, as x gets bigger and bigger and bigger, where's y going? To -infinity. Now look at this function. Top heavy, bottom heavy, tied in degree. Top heavy. And it's top heavy by 1, so what kind of asymptote do we have? Slant. Do you see where the slant asymptote could be drawn in here? If we drew it in? Okay, good. All right, 22. -infinity. As x gets bigger and bigger and bigger, y is going to -infinity. All right, 22. The limit as x approaches infinity. Now, just by looking at the graph, maybe it is approaching 0. Maybe it crosses and then it still just approaches from the top, because that could be a possibility, right? And so if we're not sure, we can look at the equation. Where is your horizontal asymptote? Give me specifically. 2/8, which reduces to 1/4. Good. They're tied in degrees, so you do that ratio. So y equals 1/4. So as x approaches infinity, y is approaching 1/4. That's what's happening there. 23. The limit as x approaches -infinity. What does it look like from the graph? -5. Can you verify that's right from your equation? Yes, because they're tied in degree, right? And I'd do 10 divided by -2, and I'd get -5. Good. All right. Limit as x approaches infinity. What does y approach? Infinity. Yes, good. All right, so I'm going to fill these in real quick, but we're not done. We got to talk about the bottom there, and we're going to come back to the little starred one. Let me make sure I fill the right ones in the right place. All right. So there are times when a limit can fail to exist. We've already looked at some of them, right? Because we've written does not exist a few times. So the first one is basically what was happening to us. If the function contains a jump and therefore approaches a different number from the left side than the right side. And I think you can see the circles on this first example fine, but I'm not sure that the lines showed up very well for you. But it looks like this. Oops. Oh, that was weird. I didn't even know I could do that. Okay. Oh, what the heck is happening now? Okay. Don't want to do that. There we go. Whatever. And I sort of missed the line, but I give up now. So when I approach a different thing from either direction, and our paths are not going to cross there, that is when the limit does not exist. That's when your two-sided limit doesn't exist. Only the one-sided limits. The second part says the function contains a vertical asymptote and therefore increases or decreases without bound as x approaches c. So here's my asymptote at -2, and that's the limit I'm looking for as x approaches -2. Now, from the left, I'm going to -infinity. From the right, I'm going to infinity, so the limit does not exist. But this wording also implies that if I had this, like on the one that we starred, it looked something like this. I have a vertical asymptote, and the function increases or decreases without bound. Here, we're heading to the same direction. Would you agree with that? But remember, for a limit to exist, the left has to exist, the right has to exist, and they have to be equal. Is infinity a number? No. So can it be equal to anything? No. So technically, even this one that we put infinity on does not exist, but we didn't do anything wrong. This is one of those things when you start discussing the theory that we're allowed to put that, but really when we get into calculus and start discussing it, it doesn't exist because the function increases without bound. But we're allowed at this point just to kind of say that it goes to infinity. All right, so I just feel like I need to throw that out there so that if you're ever told it doesn't exist, you don't get confused about why. Then the third reason is when it oscillates. Now, oscillating can kind of look like this, right, and be kind of boring, but this oscillating, it speeds up as we're getting to 0, and it's bouncing so quickly back and forth, it's not approaching anything, and this does not exist. So this, really, we probably won't see that much. This we might, but we get to talk about it as infinity, and it's fine. These not existing definitely is something that we're going to look at, okay? What questions you got? All right, so your assignment is in Delta Math, but it's not in there, and I'm not putting it in there today because that's not what I want you doing today. You have a test tomorrow, and I've already reminded you. Go back through Albert, AP Classroom, your returned quizzes, your assignments, and be ready for that test. Also, if you did not finish your reflection yesterday on page 33, finish that, okay? I want that finished by today. And then with the time that you have left, you can prepare for your test. But make sure, well, do the reflection first. Make sure the reflection's done. And then work on your stuff for your test tomorrow. Okay? We good? Questions?